enter London with lonely hearts. Oh, the warmth in your eyes swept me into.
Hello science students, we're at the Vatnajökull Glacier, or as David Attenborough would say, Glacier. It's absolutely spectacular. We're getting closer and closer to it. This looks enormous behind me, but it's actually just a small tongue coming down off it. The main part of the glacier is much higher in the high elevations. The weather's moving in on us, but we're gonna get closer and closer to see if we can't get some good views of some ice chunks, or calves as they call it. Stay tuned. Alright science students, we're here at the Vatnajökull Glacier, which is the third largest glacier in the world, and we're down at this glacial lagoon. Take a look. The Vatnajökull Glacier is located in southeast Iceland. It is believed to be the third largest ice cap in the world, and it covers about 8% of the whole country of Iceland. The average thickness of the ice is 400 meters or 1,300 feet. The maximum thickness is 1,000 meters, 3,300 feet. Hello science students, we're here in Iceland studying geomorphology. Geo meaning the earth, morphology meaning changing. And as you can see behind me, there's a glacier. And glaciers shape our earth. And a lot of people think that glaciers are stationary, but they're actually moving. Glaciers are formed when the snow falls one year and then doesn't really melt in the following spring and summer, and then more snow is added on, and more and more and more, and it can become up to a mile thick of pure ice. With all the weight of the immense snow and ice, the glacier begins to move like a slow motion frozen river heading downhill out of the mountains, carving and reshaping the earth. So it could actually act as a giant bulldozer, scraping the earth in its path and flattening things out like a pancake. If you've ever been to some Midwest states, Indiana, Wisconsin, Iowa, they've been completely flattened by glaciers. And as a matter of fact, the Great Lakes themselves were carved out as the glaciers dug deep. Now where we are in the Appalachians, the glaciers never came that far south. So that's why we've retained that rugged, mountainy feel down there. The glaciers of the last ice age covered much of what we now know as Canada and the Midwest of the United States. However, much of North America remained unglaciated. Science students, I'm standing here on what's known as a terminal moraine. It's basically a huge pile of gravel, and a lot of people might ask, how on earth did that giant pile of gravel get here? Well, that glacier that you saw acts as a bulldozer, and when it moves, it pushes the earth in front of it, just creating a giant pile of gravel. And now the glacier is starting to melt, and as it recedes, it leaves behind all the rocks that it's been pushing along. And when it does that, it will leave huge mounds everywhere in front of its path, at the end of it. And that's why it gets the name terminal moraine. Hello science students, we're now at the edge of the glacier. As you can see, it's melting. But this is part of the normal cycles that glaciers go through. In the summer, a little bit of it melts. In the winter, they add a little bit more snowpack. And what's interesting as a scientist is we can monitor glaciers. We can take pictures of them. We can watch what they do every year. And this has given us evidence that global warming is happening. And what we can do is continue to monitor them, continue to monitor the sea levels, and to predict what is going to happen to the Earth in the future. And this is just one way that scientists use scientific evidence in order to predict the future. As the glaciers melt, an enormous amount of fresh water is released. Hi science students, we're here at Skogafoss Waterfall, which is an enormous waterfall here in Iceland. It's actually a drainage from one of the enormous glaciers from the highlands. As the glaciers melt, they come down as liquid water, carving and eroding the mountainside. As the melting glaciers head down the mountains, more and more water accumulates in the rivers. Those rivers will lead to the sea. This large influx of fresh water is what is contributing to the rising sea levels we are seeing today. This picture shows a receding glacier. The first picture taken in 1938, the second picture in 1981. Notice how much of the glacier has melted in just over 40 years. Glaciers all around the world are showing a similar pattern. This graph shows as the global temperature rises, the global sea level is also rising. Over the last 50 years, temperatures have gone up, glaciers have melted, and sea levels have risen. Hello science students, I hope you can hear me over the roaring waterfall, but we're here at Godfoss, which means waterfall of the gods. And it's summertime here in Iceland, the glaciers of the high mountains are melting, and this is all glacial runoff forming this magnificent waterfall.